Today, in this lesson, we're going to be taking a look at string functions. Now, string functions are built-in functions within MySQL that will help us use strings and work with strings differently. Now, we're going to look at a ton of different ones. They all have different use cases, but I'll try to walk through some of those as we go along, but we'll look at a lot of different string functions in this lesson. We'll start off with one that's really simple. This one is called length. So if we select, and then we say length, and let's say we put in, and I don't know why it's popping up like that. Let's say we put in something like sky or skyfall or really anything. If we run this, it's going to give us the length of how long this string is. So if I come down here and we say select everything from employee underscore demographics, and let's add a semicolon here. Let's run this one right down. Now, what we can do is we can look at how long each person's name is. What we can do is just take the first name, but then we'll also do the length of the first underscore name. So if we run this, now we get Leslie, Tom, Jerry, Donna, and it gives us the length of their name. If we wanted to, we could even order by this. So we could do order by, and we could just do 2 for now. And we can order by the length from the shortest name all the way to the longest name. Now, one use case that I've used length for in my actual job was when I was working with phone numbers. I wanted to make sure that they were exactly 10 characters long. Otherwise, something went wrong somewhere in the data cleaning process. So I would go and look at the length and I would make sure they're all 10. If any were above 10, I would go and specifically look at those and try to clean those and fix those up. Now let's go on to the next one. And these next ones are pretty simple ones. At least I think they're fairly simple. We're going to look at upper first, and it's doing the same thing as the other one. We'll do upper, and let's say we're going to do sky. If we select upper sky, it's going to give us an all uppercase. Or we can copy this, and we can do lower. So now, let me add semicolons, otherwise it's going to drive me crazy. Let's try this lower now. It's going to do all lower, even if I make it all capital. So if I say all capital sky, it's going to make it all lower. So if we come back up, let's copy this. And instead of doing the length, now we'll do upper. Let's go ahead and select this. So we have Leslie, and then we have the upper first name. So upper all case Leslie. Now this is actually really good. This is really helpful, especially with standardization, is what I found a great use case for it. Because sometimes it'll be all capital Tom, and sometimes they'll put it in as T, lowercase om. And just making them all uppercase or all lowercase can help correct those really simple standardization issues within a single column. The next one that we're going to look at is trim. Now, there's multiple trims. We have trim, left trim, and right trim. Trim is basically going to take the white space on the front or the end and get rid of it, which is really, really helpful. So what we're going to do is we're going to come right here. We'll say select, and we'll start off with trim. And let me add a semicolon every time. So then we'll do trim. And for our actual string, we'll do something a little bit odd. We'll do some spaces, and then we'll do sky, and then we'll add some spaces. Now let's run this and add our semicolon. That's going to be the end of me in this lesson, just adding semicolons. Now it fixes it completely. Now, what if we don't add sky at all? We'll just keep it like this. Well, you can see that there's spaces before and there's spaces after, but that's what trim does. Trim gets rid of the leading and the trailing white spaces. Now, if we come up here and we just do the left trim, it's only going to remove from the left-hand side. So we're only getting rid of the left-hand side white spaces. This right-hand side, as you can see, is really long. It's still there. And if we do R trim, we go ahead and run this one. It gets rid of the white space on this side, but it doesn't get rid of the left space on this side. Now let's keep going. We have a lot to cover still. We're going to move on to what I think is probably my most favorite string function, if I'm allowed to have a favorite string function, and that's substring. But I'm going to kind of work us into substring a little bit by looking at 2 smaller functions, which is left and right. So let's select everything, and we'll do that from the employee demographics again. Let's add our semicolon. Now I'm going to run this. Now I want to get the first name, and I'm going to do left of the first underscore name, just like this. Now, when you're using this, there's actually going to be an error. Let's see if I highlight over this, if it'll tell me what the error is. It says the parentheses is not a valid position. They're expecting something else. And basically what they're telling us is that this is not how it should be written. We're looking for a different value. And that different value is actually a number. We're going to do comma, and let's do 4. That's what it was looking for. It didn't want this at the end. It needed this comma 4. And what we're actually specifying is how many characters from the left-hand side do we want to select. So we're selecting the first name and we're going from the left 4 characters. Let's go ahead and run this. And so we have Leslie, Tom, April, all the way down. You can see that there's only 4 characters in each one. So someone like Chris, the S is no longer going to be there because we're only looking at the first 4 characters. Now we can do the exact same thing. And let's actually copy this down here. So we'll go like this, try to make this a little more professional, and we'll do right. So now we'll do right. If we do the right 4, it's going to go from the right hand side of the string and go left 4. So we're looking at the far 4 most right characters. Now this can be useful in certain instances, but if I'm being honest, I don't use these that much. For the most part, I'm pretty addicted to using substrings. I love substrings. I think they're fantastic. And let's look at substrings like this. So a substring is going to allow us to do a few different things. Let's do first underscore name. The second thing that we put within this function is the position that we want to start at. So let's say we want to start at the 3rd position, and then we specify how many characters we want to go. So with this, we specified 4, but let's just do 2. So now we're going to the 3rd position and we're going over to the right 2 characters. Let's go ahead and run this. So with Leslie, we get SL. So we go 1, 2, and 3. We start at the 3rd position and then we take 2 characters, the S and the L. I have found this one to be extremely useful. Let's take this for example. Let's do comma. Let's do birth underscore date. And let's run this. I'm keeping everything in here, although it might be a bit much. But let's say we have this birth date and this middle column is the month. And we're running some, query. We want to find the month that everyone is born. So we can do that very easily using substring. And we wouldn't have been able to do this very easily using left or right. So now we're going to take this birth date and we're going to use this substring and we want to select these middle characters. So what we need to do, since it's all standardized, we do 1, 2, 3, 4, 5, 6. We start at position 6 and we want to select 1 and 2. Let's go ahead and run this. And now we've pulled out all of the months. So we can say as birth underscore month. And now we could save that, put it into a temp table, add it as a new column in our table, whatever we want to do. But now we have this information that we desperately wanted to know. So that is left, right, and substring. Again, substring it's fantastic. Now let's keep going. The next thing that we're going to take a look at is replace. Now replace will replace specific characters with a different character that you want. So let's actually copy all this right here because I don't want to keep writing this out. And we'll say select everything. Now what we're going to do is we're going to take the first underscore name and then we're going to say replace, and then we'll also do the first underscore name, but we can specify what we want to replace and then what we want to replace it with. So we have 2 more parameters that we need to put in this function. So let's say A, and let's replace it with a Z. Let's just see what that does. Let's go ahead and run this. And so now when we see the letter A and we are specifying a lowercase a, like Mark, that is replaced with a Z. So that's really all replace does. It specifies what you want to replace and then what you're going to replace it with. Now let's take a look at the next one. And we're going to take a look at a function called locate. So if I say select and let's do locate, I'm going to give it a string. I'll say Alexander, that's my name. And I'm going to specify what I'm looking for. So let's close this parentheses. The string that we're actually looking for comes first. So what we're going to do is I'm looking for the letter X in my name. So we'll do X and Alexander. Let's go ahead and run this. And it tells us that it is in position 4. So we have 1, 2, 3, and 4. That's where our position is. That's where it locates that sequence that we're looking for. Now, if we pull this down here, place this right here, and we'll change this locate. Now, let's say we're still looking at the first name, but we want to locate people that have an AN like this in their name. Let's go ahead and run this. And we get zeros for everybody except for Anne and Andy. So this might be something where we put it into a CTE or a temp table. Then we can filter down based off of these results to where it only equals 1. Now, the last one that we're going to take a look at, and let's go right here. We're going to do first name, last underscore name. Now, this one is super, super useful because what we can do is have a concatenation of multiple columns. So let's go down right here. So we have first name and last name, but if we come down and we say concat, we can then combine these columns into one single column. So we'll do concat, and we'll do first underscore name, and then comma, last underscore name. And if we run this, it's going to be Leslie and Nope combined into Leslie Nope. Now this doesn't look perfect, right? We don't want it to look like that. All we have to do is come in here and we could do a little space. So we'll add a space in there. And if we run that, now we have Leslie and Nope, and we could call this as full underscore name. And this is something that I've done a million times in my real job, where there's multiple columns. We want to create one column out of it, or take two columns and create one column. Happens all the time. So this concat is really, really helpful to combine those columns really quickly. Hello, everybody. In this lesson, we're going to be taking a look at case statements in MySQL. A case statement allows you to add logic in your select statement, sort of like an if-else statement in almost all other programming languages, or even things like Excel. Let's see how this actually works. So let's bring this down, and let's take this employee demographics table, and let's take the first name, and let's take the last name, and let's add a case statement. How we need to do this is we have to say case. So that's going to signify that we're starting a case statement. And then I'm going to go over here and say tab. So this is where our logic comes into play. So I'm going to say when the age, let's say, is less than or equal to 30, then. So I'm saying if the age is less than or equal to 30, then what's going to happen? We'll just keep it really simple for now. We'll just say that this person is young. And then if we want to end the case statement, we'll come down here and say end. So this is a complete case statement. Let's go ahead and run it. And let's take a look at the output. So we have the first name, we have the last name, and then we have this case statement right here. And if their age is less than or equal to 30, they're young. And let's actually add the age right here, just so we can visually see that as well. So we have the age. So this person is the only person who's under or equal to the age of 30. That's April. So she has a label of young. The great thing about case statements is you can add multiple when statements. So we can come down here and say when, and then we could do something like when age, and maybe we'll say between. So I don't know if in previous lessons we've looked at between, but between just says between this number and this number. So we'll say between 31 and 50. If they're between 31 and 50, well, good night. That person is old. So we're going to have it just like this. We're going to run it. And now we have a lot of people who are old. These are all people between the ages of 31 and 50, but we still have more people outside of the age of 50 or older than 50. So we could do when the age, and now we can say greater than or equal to 50. And we're going to say then, and then we're going to say on death's door. Because good night. If you're over 50, my parents are going to love me for this one. So let's go ahead and run this. And then if we look at this, we have on death's door right there. Now this is huge. This is massive. So let's actually name this, and we'll just say as at the end of end. So right after end, we'll say as age bracket. And let's run this. And this looks a lot better. So now we have this age bracket, just signifying kind of where people are at, and most people are quite old. Poor Jerry, can't catch a break, that guy. Now let's go down and let's take a look at a different table. So let's select everything. We'll do from employee underscore salary. Now that we have our employee salary table, here is the scenario that we are given. The Pawnee Council sent out a memo of their bonus and pay increase for end of year. And we need to follow it and determine people's end of year salary or the salary going into the new year. And if they got a bonus, how much was it? So the first thing we need to do is we need to get the pay increase and bonus. And their pay increases look like this. So if they made less than 50,000, then that equals a 5% raise, very generous. And if they made greater than 50,000, that equals a 7% raise, very, very generous. Lastly, if they work in the finance department, that equals a 10% bonus, just cash that goes into their bank account. Very, very generous, but only the finance department gets it. So these are the guidelines that the Pawnee Council sent out, and it is our job to determine and figure out those pay increases as well as the bonuses. So let's come right down here. We're going to have our salary employee. I actually want to be able to see these. Let me pull this up just a touch. There we go. So we want to be able to write this out. So first thing we should do is just select the columns that we need. First name, last name, probably salary as well. And now what we can do is determine this first one, which is if they make less than 50,000, they get a 5% raise. So let's say case, and I'll also add end in here. And we're going to say when their salary is less than 50,000, what's going to happen? Then we say then salary. So we're taking their initial salary and we're saying plus, then we're going to do salary times 0.05. And if we run this, it should work. Let's pull this up really quickly. So April Ludgate, she made under 50,000, so she got a raise, and her new salary is 26,250. We can actually call that. We'll say as a underscore. Actually, let's do new underscore salary because that's their new salary. And let's run this. So the new salary is 26,250. Andy Dwyer is now making 21,000. Now this calculation, you can do it different ways. We can do it exactly like this. Or we can just do times 1.05, should be the exact same thing, just however you would like to write it out. It's just, adding it or multiplying it by this. So let's take this. And now we're going to say when it is greater than 50,000, so let's say greater than 50,000, they get a 1.07. So this is the 7% increase. This is a 5% increase. This is a 7% increase. And let's run this. And let's put this up here. So now if they made greater, so 50,000, that's 75,000, they got a 7% increase. Now, unfortunately, we did not make the rules, the Pawnee Council did, and the people who made exactly 50,000, unfortunately, were not part of those brackets, and that just wasn't up to us. We couldn't control that. So unfortunately, Tom Haverford and Jerry Gergich just didn't get raises this year. And that's not our fault, okay? That's not our fault. Now, the next thing that we need to do is determine the bonuses. Now, let's come right back up here really quickly, and let's just copy this, because what we need to determine is how we know that somebody is in the finance department. Because if they're in the finance department, that means they get a 10% bonus. That's really important. Now, it's not in the employee demographics. Don't have anything about the department. But if we look in the salary and we run this, we do have the department ID. Now, let's open up and let's pull this up right here. We'll look at the Parks department. And in the Parks department, here we go. The finance is department ID of 6. So if we're looking at the salary, there's only one person who's in department ID equal to 6. So what we can do is another case statement. We can say, comma, we'll do case and end, and we'll do another one. We're going to say when DEP-TID, so when the department ID is equal to 6, then we're going to give them a bonus. So we're going to say salary times 0.10, and we'll call this as bonus. Let's go ahead and run this. And let's pull it up. So he gets a $7,000 bonus this year. That's Ben Wyatt. because he was part of the finance department that just did an exceptional job this year, apparently, according to the Pawnee Council. So that is how case statements work. They're really powerful, really useful. I honestly use them quite often, and they're just a way to really add some logic and some, labeling or even do calculations like we did right here with the salary. Hello, everybody. In this lesson, we're going to be taking a look at subqueries in MySQL. Now, subquery is basically just a query within another query. We can do this in a few different ways, and I'm going to try to show you a lot of the different variations within this lesson. The first way that we're going to use a subquery is in the where clause. Then we'll take a look at the select and the from clause also. Let's take this demographics table that we have down here. What if we only wanted to select the employees who worked in the actual Parks and Rec department? Well, we could do that if we had a few joins. We have this salary table, and one actually represents that they work for the Parks and Rec. If we come over here and we open this up, we can see that Parks and Rec is the department ID of 1. So we do have that option. We could just join these two tables together, but sometimes we don't want to do that, and we'll use a subquery. Let's see how it works in the where clause. So let's go ahead and get rid of this. So what we're going to do is we're going to say select everything from employee demographics where, and now we want to pull, because this is the salary table, we want to pull employee IDs where the department ID is equal to 1. But remember, we're querying off of this table. So let's actually pull this up. This is what we're working with. So we want to say where the employee underscore ID, that's referencing this column in the demographics table, is in, what we're going to do is we're going to do a parentheses here, and we can even come down and put a parentheses down here. So what we're going to do now is write our query, which is our subquery, and this is our outer query. So now we're going to write an entirely other query within this. So we'll say select, and now we're going to say employee underscore ID, and let's just bring this over. I usually have it something like this, and I'm going to try to bring this down a little bit. So select everything, and then we'll do from, and then instead of employee demographics, we'll do employee salary. And let's just format this a little better. So select the employee ID from employee salary, and remember we wanted to do where the department ID is equal to 1. Now let's bring this back up, and this is what the query is going to look like. Now, just by itself, let's run this subquery or this inner query. When we run this, it's going to create this list of just employee IDs where the department ID is equal to 1. So when we say where the employee ID from the employee demographics table is in, it's going to try to match those employee IDs to this list of employee IDs. So just remember 1, 2, 3, 4, 5, 6, and 12. Let's go ahead and run this entire query. Now we have 1, 3, 4, 5, 6, 12. If you remember from previous lessons, the 2 is Ron Swanson, and he's only in the salary table. So since we're doing just the employee demographics table, he's not in here. So what we're doing is we're selecting everything from the employee demographics where the employee ID in this table matches or is in the select employee ID from the salary table where the department ID is equal to 1. In essence, this is what a subquery is. It's a query within a query. Now, what would happen if we have the employee ID, but we also wanted to say the department ID, because we just wanted to view this. Let's go ahead and try to run this. We are going to get no output, and we're going to get an error that says operand should contain 1 column. The operand referring to this entire thing right here, because this is an operator. So this is our operand, and we're returning 2 columns in here, which is saying we cannot do. We have to only have 1. So now if we run this, it works perfectly well. And let's bring that down. Now we can also use the subquery in a select statement. So let's take a look at that next. Let's go down here, and let's say we want to do select everything from employee underscore salary. And let me spell that right. Let's say we want to look at all the salaries just like how we have it now, but in a column next to it, we also want to compare it to the average salary for everyone. So we'll be able to see, whether somebody's salary is above average or below average. So what we would try to do potentially is do something like first underscore name, salary, and average salary. And we try to run this. And of course, we're going to get an error. It's going to basically tell us that we need to group by if we're doing this. So let's go back down and let's actually add that group by. And we'll say group by first name and salary. And we'll look at this output. And this is not looking good at all. It's just looking at the average salary for each unique row, which is Leslie 75,000. So the average is 75,000. This is not what we're looking for. This is not what we want. Here's what we really do want. We want to just take the average salary of this entire column, regardless of group by or anything else. So let's get rid of this and let's see how we can do that. So let's come right down here. We're going to say select the average salary. And then we're going to say from, out of parentheses, because this is our subquery, from the employee salary table, just like that. Now, if we run this, we should get the exact output we're looking for. So the average salary is $57,250. And we have our salary right here. So we can compare really quickly, just like that. Now we can also use a subquery in the from statement. So let's go down here and let's say select everything from employee underscore demographics. Let's have it autocomplete for me. So we have the employee demographics table. Now let's create a group by based off the gender column and add some aggregated functions. And I'm going to show you how you can use this as a subquery. Let's go up here, say gender, and then we'll just go ahead and add our group by. So we'll say group by gender as well. Now let's add a few things. We'll do average, we'll do average age, and then we can do, let's just do all of them based off the age. We'll just do age, min of age, and count of age. Whew. When I try to write fast, it doesn't always go right. So we have this, let's run this. And this is what our output is going to look like. Now, what if we wanted to get the average of the oldest age or the average of the smallest ages, or see what the average count is for males and females? Well, we can't do that given this table, but let's do something right here. Select everything, and then we're going to say from, and in our from statement, we're going to have a parentheses. We're going to paste our select statement and then close the parentheses. So we're going to select everything from this output that is right down here. So if we run just this, we're going to get an error, and forgot this was going to happen, but every derived table must have its own alias. So you have to name a table. I forgot it does that. All we have to do to fix this is just name it. So we'll say as, and we'll say aggregated table. We'll just call it aggregated table. So let's run this, and we get the exact same output. But here's the neat thing is we can now select, we can do gender, and these are actually the column names now. So I can do the average of this column right here, but I can't do it just like this because it's going to give us an error. And I'll show you why in just a second. It says unknown column age in field list. So what it's saying is we're trying to perform an aggregated function on the aggregation of an age column, but we don't have an age column in our table right here. Let me run this again. We have a column named this exact thing. So what we actually need to do is do this backtick and backtick. This is the actual name of the column. It's not an aggregation anymore. The backtick on my laptop is right above the tab on the far left-hand side, right under the escape. That's where mine is. So these backticks, it's not a quote like this, it's a backtick. So you just need to find that on your keyboard. But now if we run this, it looks like we encountered another error. It says in aggregated query without group by. That's right. Now we need a group by. So now we need a group by gender. Sometimes you got to figure this out on the fly, and it should work. There we go. So now we can perform aggregations on this table. Now, this doesn't actually work perfect because we're still grouping by the female and male, but let's get rid of this for a second, and we'll get rid of this group by entirely. And if we run this, we're now looking at the averages of this column right here, max age. Now, when you're doing something like this, it's actually really smart to rename these. We'll say as average underscore age. We'll say as max underscore age, and it makes it so much easier. You don't have to do these backticks anymore. And as min underscore age, and so on and so forth. And I would probably format this better and stuff like that. But we don't have to go through everything, right? I'm just kind of giving you an example. But then when we're using this table, these columns are actually named this. So I don't have to do these backticks anymore. I can just take this whole thing. Oops, get rid of that backtick. Now I can just take this column because this is the column name. So let's go ahead and run this, and it's still going to work perfectly. So this one's pretty cool because you're basically creating this kind of like a temp table. You're just creating your own little output. Then you can query off of it, and you could do more advanced calculations this way. It's actually really useful. But there are better ways to do something like this, like a CTE or a temp table that we'll look at in the advanced series. But this is at least how you can do it, and you can actually try it out using Subqueries.